39, balance each of the following equations according to the half reaction method. And then we have letter E. So in this case, we have to balance HBrO aqueous, which will yield Br minus aqueous plus O2 gas. And they told us specifically that we need to balance this in acidic conditions. So I gave you all the rules in how to balance a redox reaction in an acidic solution or in acidic conditions. So let's get going. The first thing we got to do is we have to break this whole equation into half reactions. So I'm taking a whole reaction and I'm breaking it into two. So in this case, you have to put the like elements that are the similar on both sides. Don't worry about oxygen and don't worry about hydrogen because you will be able to balance those in the next coming steps. So focus on all the other elements that are not oxygen and hydrogen. So for example, I have this whole compound on the left-hand side, right? And I have a bromine here. So this would probably or definitely hook up with this component. Bromine goes with bromine. So that's one half reaction. But now I have a lonely oxygen, right? And I don't have anything else on this side to match it up with, right? There was no other compound to match it up with. But that's okay because oxygen is going to get balanced out in step 3. So I have my two half reactions here. I have this going to this, and I have this lonely guy, but we will balance that out in the upcoming steps. So let's just write them out. I have HBrO. Ooh, let me actually pull this over. I have HBrO, and that's aqueous, and that will go to Br minus. And now I have another reaction in which I have a yield sign, and O2 is on this side. But don't worry, because we will be able to add something here in the upcoming steps. So our first part is done. Now, let's go to the next step. The next step is to balance all of the elements except for hydrogen and except for oxygen. So don't look at hydrogen and oxygen here. Look at all the other elements. There's only one of them that I see. I only have a bromine on my top equation, right? But if I look at it, I have one bromine and I have one bromine. So that's already balanced. So this step is done. Now let's go to the third one. Now we're going to balance the oxygen by adding H2O. And just know that oxygen before hydrogen, okay? So always balance oxygen first. And little quick thing here, if you need to add one oxygen on one side of the equation, you will always add it in terms of one H2O. So if you needed to add two oxygens on one side, you'll add two H2Os. 3 oxygens, 3 H2Os. Let's work with the top. I see that I have an oxygen here, right? So that's one oxygen. And I don't have any oxygens on this side. So one oxygen, one H2O. So I'll say plus 1. Now I don't really need the 1, but I'll just say H2O. There you go. Now let's work with the bottom. Well, I have an oxygen here, and I have 2 of them, right? I have no oxygen on this side, so I need 2 oxygens, 2 H2Os, and now I have a half reaction. So there you go. You see, it always comes back. Now I need to balance the hydrogens by adding H+. Rule of thumb, if you need to add 1 hydrogen, you need to add 1 H+. Don't forget that positive, okay, guys? So let's see, on this equation, I have 1 hydrogen on my left side, and I have a hydrogen here. I have 2 of them. So I have a total of 2 on my product side, and I have 1 on my reactant side. I need to add more on this side, but how many more? I already have 1, so I only need to add 1 more to get to 2. So I will add 1. We don't have to put the coefficient, but just say H+. Now we got to do the same for the bottom. Well, here's a hydrogen, right? I have 2 of them, but now I have a big 2 coefficient. That's multiplication. So I have a total of 4 hydrogen here. I have no hydrogen on this side, so plus 4 H plus. For every 4 hydrogens I need, I add 4 H pluses. And that step is done. Now we need to balance the charges by adding electrons. And electrons are E negative. We always add the electrons to the more positive side. So I got to break this up. Just makes it easier for me to visualize. I'm going to take the overall charge of this and compare it with the overall charge of this. Always look in that upper right-hand corner. So I have a plus charge for my H. That means that it's a plus 1. And I only have 1 of them. So this is telling me that I have a plus 1 charge. And maybe I'll just write it above it. Now this one, I don't see any charges in the upper right-hand corner. So it's neutral, which means that it's a 0 charge. It's not positive nor negative. So overall 0 coming in here. And now we just have to add the values together. So plus 1 plus a 0. The total would be a plus 1 on this side. So I have a plus 1 overall charge. And now we just got to do the same thing over here. Well, I see that I have a negative, so that means a negative 1. I don't see a number here, so that means I only have 1 of these. So overall negative 1 for the bromine. And for my water, I don't see a number, so 0, it's neutral. Add them up. Negative 1 plus 0 is a negative 1. So here are my 2 numbers. Which side is more positive? We add electrons to the more positive side. Plus 1 and negative 1. Plus 1 is more positive, so I know that I have to add electrons on this side. But how many of them? On a number line, how many numbers do you jump from a plus 1 to a negative 1? 2, right? I got to go to the 0, and then I go to the negative 1. So that's how many electrons you add, the difference between the 2 numbers. Now we do the same thing for the bottom. I don't see any value up top here. So that's neutral to 0. I don't care that I have 2 of these. 0 times any number is 0. So my overall charge for this side would be 0. And now I do the same thing here. O2, I don't see a charge here. So that's 0, right? But now I see that I have a plus 1 for my hydrogen. And I have 4 of them. So you got to multiply. 4 times a plus 1 is a plus 4. And now you just add the 2. 0 plus a positive 4 is a plus 4. Now we compare. Out of a 0 and a plus 4, the plus 4 is more positive. So I know that I have to add electrons to this side. And how many? Well, what's the difference between? How many jumps do I have to go from a plus 4 to go to a 0? Yeah, 4 numbers, right? So I need to add 4 electrons. And now this step is done. Now this is a checkpoint, guys. Your electrons that you added should be on opposite sides. And they are in this case, which means I will proceed further. But if you had like 2 electrons on the same side as the other electron, go back. Something happened, all right? Now what I'm going to do is I'm just going to make this a little bit more easy on the eyes here. We did all this work. But now we don't need this work anymore. Okay, and for this one, so all we just need is that electron answer. Okay, and there we go. Okay, so now we're down to this. The next step is now we have to balance those electrons. We balance the electrons by multiplying. I have 2 electrons and I have 4 electrons. We want to get to the lowest possible number that's common between them by multiplication. So what would be the number in common between 2 and 4? Well, if I just multiply this whole equation by 2, 2 times 2 would be 4. So that's the lowest possible number. So I need to multiply this whole equation by 2. I don't have to do anything with this side because then the electrons would be balanced. So when we do this, you have to change every single coefficient number. You have to be fair. you have to multiply and change every single number, okay? So what I'm going to do is I'm just going to walk you through it. But if you want, rewrite it, but I'm just going to erase and replace the correct number. So for example, I know I have to multiply everything by 2, so I have 2 electrons. 2 times 2 is 4. So now this would be 4 E minus. I have 1 H plus, but 1 times 2 is 2. So now it becomes 2H plus. I have 1 HBrO. 1 times 2 is 2. Moving on to this side, I have 1 Br minus, but 1 times 2 is 2. And then I have 1 H2O, but 1 times 2 is 2. And once I put my new coefficients, I'll just erase this. And that is my new half reaction for the top. And still, the electrons are the same. So we're done here. Now, we did this for a reason. We never see electrons in a final balanced equation. They're there, but they're just canceled out. So that's what we have to do. We have to cancel out like substances that are on opposite sides. All we're doing is simplifying. So the 4 electrons, they're the same on opposite sides. They go bye-bye. And now let's look and see if we can cancel anything else out. Well, I have 2H plus, and I have 4H plus on this side. We get rid of, or simplify by subtraction. So I have 2 and I have 4. If I use up all of my 2 on this side, how many would be remaining here? Well, it's basically 4 minus 2H plus, because that's what we had over here. So 4 minus 2 is now I have 2H plus remaining. So that's the simplified one. And let's see, what else? Oh, I have 2 H2Os on this side. And I have 2 H2Os on this side. They're exactly the same number, so they get canceled out. Nothing else that I can cancel out, so now I'm just going to rewrite everything that's remaining on the left side and everything that's remaining on the right side, right? So let's just get down to it. So we have 2 HBrO, and that's aqueous. Yields, I don't write anything else out because it was all canceled. 2 Br minus, aqueous, plus O2 gas, plus 2H plus. And that is your final answer. The final answer to balancing this redox reaction. That's it. Okay. What do you think, guys? Hopefully this helped. Let me know in the comments what you thought. Give this video a like, subscribe to the channel. Thank you, thank you, thank you, thank you. And love you guys. You guys rock. Good luck on your tests and quizzes. Keep working hard. I will see you in the next lesson. Bye-bye.